Okay, the next feature I would like to show you is hole. So first, let's see the hole types in ZW3D. We provide three hole types: general hole, clearance hole, and threaded hole. And through the hole location, hole shape, and the hole specification definition, finally we can get the hole features. Now first, let's see the three hole types. So in ZW3D, we have general hole, clearance hole, and the threaded hole, as I said before. So for the general hole, which means you just need to input its diameters and other values. But for clearance hole, all you need to do is define the screw size and the fit type, like close, loose, or etc. And for threaded hole, you need to define the hole diameter and the thread diameter. Okay. And in ZW3D, we have four common hole shapes: simple hole, tapered hole, counterbore, and countersunk, which you can see it in the below image. Okay. There are some settings in the hole creation. The first one is add chamfer. In ZW3D, you can add chamfer for the holes along with the hole creation. For example, for this counterbore hole, we can add the chamfer for the start, middle, and the end side. The second settings I'd like to show you is the tolerance. In ZW3D, you can create the tolerance for the hole. You can just type it, the value. You can just type the value like upper limit and the lower limit, and also you can use the tolerance belt to define the tolerance. And after that, you can show the tolerance in the PMI or also in the 2D sheet. Okay. And the next feature I would like to show you is the modify holes and the flag holes commands. So for modify holes, it's very easy to understand. We can use this command to batch modify different types or different specification holes to fix the type and the specification. Like here in the left side, you can see there are several holes with different types. So we can use the modify hole command to change it identical. Okay. And for flag holes command, we can use it to change the parametric free holes or Boolean holes to parametric holes. Like here, you can see we have imported shape which have no modeling history. So we can flag these two cylinder faces as hole features. You can see like this. Okay, now let's move over to ZW3D to show you more details. Okay, here we are. So first, let's see the hole feature. Now you can see we have three hole types: general hole, clearance hole, and a thread hole. So for general hole, actually it's very simple. We just define its location. Here is a little tip. In this location, you can use the right-click menu to define its location precisely. Like we can make the offset. We define the ref point and the x offset and the y offset, even z offset. Okay, after that, the location will be fixed. Here. Okay. And next, let's see the specification. Here you can see for the general hole, we just input its diameter. Like we change it to 8, and it will be smaller. And then we can add the start chamfer and end chamfer. Here we just add the start chamfer. Okay. And here we can add the tolerance, like the upper 0, 0.1, 0.02. Okay. After that, we can click OK to get the result. It will be like this. And then we can see the second command. Sorry, it's the second type. It's the clearance hole. Okay, for clearance hole, actually, we do not need to input its diameter. All we need to do is define the screw size. Like the screw is M8, and then you can see the fit type we need to define. For close, the diameter will be 8.4. For normal, it will be 9. For loose, it will be 10. And you can also custom the diameter. Here we can use the close. Okay. And the other options is similar to the general hole. Okay. Now we can get the result. And for the last one is the thread hole. It's too big. Make it M8. And we define location, and then we define the thread parameters. Like here we can use the M8 multiplied by 1 or M8 multiplied by 1.25. Okay. Now you can see the result. Now we can now we can make the PMI for the host to see the difference. Hole cool out. Now you can see the difference between these three hole types. Okay. And there is another important option for the hole. It's about the hole alignment. For example, if we want to make a hole in this inclined face, for example, we want to make 3 holes in this inclined face. But by default, you can see the hole direction is perpendicular to the inclined face. So the result will be like this. But if we want the hole direction to be parallel to the Z direction, what should we do? So here I'll show you how to do it. So it's in the hole alignment. We just define the direction. Here we can use the Z axis. It's -Z. Okay, now you can see the preview. Now it will be changed to the Z direction. Okay. And the next, I'd like to show you how to use modify holes command. So this command is used for change the parameters for multi-holes. For example, here we have 3 holes with different parameters. Now we can change it in batch. First we select the 3 holes, and then we change the hole specification. We make it thread holes, and we make it counter bore as the hole shape, and we make the parameter as M12. Okay, and then we change the height. Okay, and then we can make it a through all. Okay, now we see what will happen. Now you can see we have changed the 3 holes as a threaded hole, and it's all counter bore. So this is the usage of modify holes. And the next, I would like to show you flag holes command. we have got a imported part which has no modeling history. So if you want to make the whole call out, you can see you cannot select the cylinder face because it's not a hole in ZW3D. So this is where we can use the flag holes. Okay, so the required input is a face and the cylinder face. Okay, and then we can define the hole specification. Like here we make it M30. Okay, now you can see it's a hole in ZW3D right now. Okay, now if we try to make the whole code again, you can see it succeeds. The next feature I'd like to show you is rib and rib network. In mechanical design, we often need to make a rib. So in ZW3D, we profile two commands to create such features. The first one is rib. We can use this command to create a single rib feature by an open profile. And all we need to do is define the profile, the thickness of the rib, and the draft angle, and also the boundary. Then we can get a rib feature. And for the rib network, we can use this command to create a network of interconnected ribs. And we do not need to care the length of the profile because we can trim the rib in this command. Okay, now let's move over to ZW3D to show you more details. Okay, so first let's see the rib command. This can be used to make a single rib. Like here we already have a profile. We select it, and then we can define the directions. Then we can define the direction of the rib to parallel or vertical. So apparently here we need parallel. Okay. And the next one is the width of the rib. We can make it bigger or smaller. Okay. And also we can draft the rib when we're creating the this feature. We can give it 3 degree to draft. And then we define the stationary plane. This one. Okay. And then we define the boundaries. Okay. Then you can see the rib feature is created. And here you can see actually it has a draft angle here. So this is very convenient. And also for the draft for the rib feature and also for the rib feature, we can define multi boundaries. Like here, here we can make the draft angle to be 0. Okay, now you can see this is the result. Okay, this is about the rib feature. And for rib network, it's much more powerful. So here you can see we have two sketch in different direction. This is along x direction and this is along y direction. So here we can make it as the path of the rib network. Okay, now we can see how to use it. Profile. First, we select the profile in the x direction, and we make it like 0.55 as the thickness, and we add it to the list. And we select another profile, and we can make it like double 0.5 and add to the list. Then you can see different profiles with different thickness. Okay, and then we define the start side and the end side of the rib network. Like the start, we can make it -2, and at the end we can make it as the bottom. Okay, 0.2. Okay, and also we can make the draft angle here. And another one is about the boundaries, because by default you can see the result will be over the this product. This is not what we want. So here we can redefine it, and we define the trim boundary. This face, 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 all faces, and the cylinder face in the middle. Okay. Now you can see it's much more better. We can hide the sketch to see it more clearly. Okay, now this is the result. Very, very, very good, right? Okay, this is all about the rib and the rib network feature. Okay, next I'd like to show you the thread, solid thread and the cosmetic thread. In ZW3D, we have both thread types, solid thread and cosmetic thread. So for solid thread, which means you have to create a solid feature by revolving a closed profile around a cylindrical face. So this one is very easy to understand with the below image, like this. And for cosmetic thread, which means you can make a like texture thread along the cylinder face. Okay, so in ZW3D, we always recommend you to use the cosmetic thread, because it will more efficiently and save you more time to regeneration, and also you can get a smaller model size. Okay, so now let's move over to ZW3D to show you more details. Okay, now let's see the solid thread. Okay, all you need to do is select the cylinder face and a profile. Then you define its turns, like we make it 5, and the distance we make it 8. Actually, this one is very similar to the spiral sweep, and also we can define the Boolean operation here, and also the lead in and the lead out. Like here we make both ends to lead in. Okay, and here we have more settings, like clockwise or anti-clockwise. Okay, now you can see the result is as below. And for the cosmetic thread, we use the flag external thread command. So this one is very simple. We just select the cylinder face, and we define the thread specifications. Like here we use the M40 multiply 1.5. The length type can be by default. You can see there is a length, and also you can make it 1 times or like 2 times of the diameters, like this. And also we can just use the full. It will cover the whole cylinder face. Okay, and then we click OK to see the result. Okay. Next, I'd like to show you lip and the stock feature. So for lip feature, we can create a leap feature based on two offset distances. And there is the step you need to pay attention to. So which is select the edge, define the first offset site, and then input the offset values. Okay, later I'll show you in the software. And for stock, actually is very easy to understand, which means we can create a cuboid or a cylinder that completely surround a single face, shape, or point block. Okay, and there is just one option you need to pay attention to is about the aligned plane. So which you can control the stock size of an inclined part. Okay, something like the below image. Okay, now let's move over to software to show you more details. So now I'll show you how to create a leap first. Click leap, and we select edges, and then we define the first site, this one, and then we define the offset values like 0.2 and 0.5. Okay, we can make it a little bit bigger. Okay, now you can see the result. We can change the color to show you more clearly. Okay, now you can see this is the leap feature. And for stock, actually it's very easy to understand. We can create a block or cylinder by a single face or multi faces or a whole shape. We unpick last and we select the whole shape. Okay, we can click OK to get the result. And also it can be a cylinder. Axis. Okay. And there is one option you need to know. It's about the plan. Okay, so you can see for this part, it's an inclined part, which means we need to define the aligned plan to make it the minimum stock. Okay, we can select this one as the aligned plan. Now you can see it's more reasonable, right? And also you can adjust the size of the stock. Like you can make it bigger or smaller. 10 here. Okay, this is the result.